our third lab, we analyzed the path of a star around a black hole. In this lab, we use Newton's second law, which states that force is equal to ma, and the gravitational force law, which states that the gravitational constant times the mass of the first object times the mass of the second object divided by the radius of those two objects squared is equal to the force due to gravity. Using this and all the data that I was given on WebAssign, I found that the mass is equal to 1.9 times 10 to the 31st. This means that given the path of an object, along with the position and mass of a second object, we can determine the mass of the second object that is acting on it. I started by inputting the data that we were given in the WebAssign. That is the mass of the star, delta t, and the position of the black hole. I then input the universal gravitational constant. I changed the name of my CSV file so it would match the name of my code. The next thing I had to change was this section. I had to calculate the velocity in the y direction, so I did something very similar to the x velocity which is given. I took two consecutive y positions and found the difference of those two. I then divided that value by delta t, which gave me the velocity at that time. I'll use this value later in my analysis. The next part to calculate is the momentum, denoted by p. Because p equals mass times velocity, p initial equals the mass of the star times the initial velocity. Similarly, the final momentum is equal to the final velocity times the mass of the star. Next, delta v equals the final velocity minus the initial velocity. Same with delta p, only with momentum instead of velocity, where final minus initial equals the change in momentum. Then dp dt equals delta p divided by delta t, as written here. This is equal to F net according to Newton's second law. Next, I found the components of F net, which are F net parallel and perpendicular. I found the first by finding the unit vector of the momentum, which I multiplied by the difference in the magnitude of the final and initial momentums. I then found the perpendicular force by subtracting the parallel force from the F net. This is equal to the F net perpendicular. I found R by finding the magnitude of the difference in positions of the star and the black hole. This is the radius. I then found the mass of the black hole by using the gravitational force law. By rearranging the variables, I set the mass of the black hole equal to the magnitude of the total force times r squared divided by g and divided by the mass of the star. Because this is in the while statement, this gives a lot of different masses each time it goes through. I put each of these values into an array, which I then found the mean of. This gave me the mass of my black hole. When I run my code, this is what I get. As you can tell, I was not given too many points, so I was only given just a small portion of the circle, or the orbit. Even with just a few points, though, I was able to determine the mass of the black hole. Right here is the mass of my black hole. I was given this value because at the bottom of my code, I had the code print out the average of the array of all my masses, which I explained earlier. To reiterate, given the mass of a star and its path around a fixed black hole, we were able to determine the mass of that black hole. We were able to do this with the manipulation of Newton's second law and the gravitational force law, both of which are shown here. Now for what does this mean? The difference between dp dt and F net is the difference of cause and effect. F net is the cause of a change in momentum. It is a coincidence that these two are exactly the same. That is to say, there's no way to mathematically prove that these are equivalent. It's a fundamental theorem that was found through observation, not mathematical proofs. We were then asked to think about if the black hole had changed in any way. If we were to make any changes to one variable in this scenario, then the force would change, which would change the path of the star. Therefore, there can only be one true mass of the black hole to obtain the values that were given in the CSV file. However, if more than one variable were changed, there could be potentially an infinite amount of possibilities.